Intersecting lines. There are two methods for finding where two lines intersect. Number 1, graph the two lines, read the point of intersection from the graph. Number 2, find the point that satisfies the equation of both lines. We do this by solving the equations simultaneously. M is the line x plus 2y minus 4 equals 0, and n is the line x minus y minus 1 equals 0. Part 1. Using the same axes and scales, draw the lines M and N. Part 2. Use your graph to find the point of intersection of M and N. Part 3. Check your answer by solving the equations simultaneously. So part 1. Using the same axes and scales, draw the lines M and N. We graph the lines by finding the coordinates of the x-intercept and the y-intercept for both lines. So basically, for both lines, we let y equal to 0 and find an x value, and that's going to be one of our coordinates. And then we let x equal to 0 and we find a y value, and that's going to be our other coordinate. So starting off with line M, which is x plus 2y minus 4 equals 0. So we're going to let y equal to 0. So we're going to swap that y for 0, so it'll become 2 by 0, and that will cancel out the 2. So it's going to be x minus 4 equals 0. So x minus 4 equals 0, so x is equal to 4. So what we did was we swapped the y for 0 with brackets around it, and 2 multiplied by 0 will cancel. So we're left with x minus 4 equals 0. And the minus 4 comes over the equal sign and becomes plus 4, so x is equal to 4. So if x is equal to 4 and y is equal to 0, then the point 4, 0 are the coordinates of the x-intercept. So this is the point at which the line will cross the x-axis. Next, we're going to let x equal to 0. So we're going to have 0 plus 2y minus 4 equals 0. So we're going to get rid of the x basically. We'll be left with 2y minus 4 equals 0. We bring the minus 4 over the equal sign, it becomes plus 4. And then 4 divided by 2 is 2, so y is equal to 2. So basically what we did was we swapped the x for 0. So we had 0 plus 2y minus 4 equals 0. So we obviously just get rid of the 0 cancels out, so we've got 2y minus 4 equals 0. So the minus 4 comes over the equal sign, becomes plus 4, and 4 divided by 2 is 2, so we get y is equal to 2. Therefore, 0, 2 are the coordinates of the y-intercept, so the point at which the line crosses the y-axis. So x is 0 and y is 2. This is our y-intercept, 0, 2. Now we're going to do the same thing, but with the other line, which is x minus y minus 1 is equal to 0. So again, we let y equal to 0. So this becomes x minus 0 minus 1 equals 0, which gives us x minus 1 equals 0. We bring the minus 1 over the equal sign, it becomes plus 1, so x is equal to 1. So basically what we did was we let y equal to 0, so we swapped that y for a 0. So we become x minus 0 minus 1 equals 0. But we can just cancel out the 0. So we have x minus 1 equals 0. So x minus 1 equals 0. And the minus 1 comes over the equal sign and becomes plus 1. So x is equal to plus 1. So the coordinate 1, 0 is the x-intercept. So 1, 0 is the point at which this line will cross the x-axis. And now we're going to let x equal to 0. So this x here becomes 0. It's going to be 0 minus y minus 1 equals 0. So then we get minus y minus 1 equals 0. The minus 1 comes over the equal sign, becomes plus 1. So we've got minus y equals 1. And we're going to change this to a plus and this to a minus. We get y equals minus 1. So what we did there was we swapped the x for 0. So we've got 0 minus y minus 1 equals 0. We can cancel out that 0, leaving us with minus y minus 1 equals 0, which is what we have here. The minus 1 comes over the equal sign, becomes plus 1. This minus y becomes plus y, and this 1 becomes minus 1, so we change the signs. So 0 minus 1 is the coordinates of the y-intercept. So this is the point at which our line will cross the y-axis. Now alternatively, what we could have done was rearranged each of the equations so that we have the y on its own, and then we could have used the f of x function on our calculator. This is known as the table function, and we could have inputted a number of x values. Now the problem with that is we wouldn't necessarily know where to start. So an idea might be to start at -3 and end at 3, or start at -5 and end at 5. So that would when we are doing this method, personally I think it would be a good idea to get an extra point for each, or an extra coordinate for each of the lines. So maybe letting x equal to 1 and substituting it into this formula, and then letting x equal to 1 over here, or 2 or 3, it doesn't have to be 1. The reason why it's a good idea for that is if you made a mistake with your working out, you're not going to know you've made a mistake, because you'll still come up with 2 points. You'll plot them and they will join together to form a line, but you won't know if the line is correct. However, if you had 3 points or 3 coordinates for each of the lines, if they did not line up, you would know that you'd made a mistake with one of your working out, and if they did line up, you'd know you're correct. So it would be a good idea to get an extra coordinate for each of the lines. Part 2, use your graph to find the point of intersection of M and N. So we have to actually plot our points and then join them up. So if I start with 0, 2, so this is my x-axis and this is my y-axis. I go to 0 on my x-axis, which is here, and 2 on my y-axis, which is here, and plot that point. And then I have the point 4, 0, so I go to 4 on my x-axis, which is here, and 0 on my y-axis, which is here, and plot that point and join them together. So now I have the line M. Next, I'm going to plot the point 0, minus 1. So I go to 0 on my x-axis, which is here, minus 1 on my y-axis, which is here. So that's the point 0, minus 1, plot the point. And then the point 1, 0. So I go to 1 on the x-axis and 0 on the y-axis. So that's that point here, and plot the point 1, 0. Then I join them up. Make sure to extend your line as far as you can. And I can clearly see that this is the point at which the two lines cross or meet. So this is known as the point of intersection. And it is 2 on the x-axis and 1 on the y-axis. So 2, 1 is our point of intersection. So reading from the graph, the point of intersection is 2, 1. Part 3, check your answer by solving the equations simultaneously. We solve simultaneous equations by eliminating either x or y. We do this by multiplying one or both equations to get equal numbers of one variable in both equations. So that means basically get the x's to match up, or else get the y's to match up. One needs to be a negative and one needs to be a positive, and then we can cancel them out. In this example, we have equal numbers of x's in both equations. So we have an x in the first equation and an x in the second equation. So the numbers in front of the x's are 1, so they both match up already. So if we subtract one equation from the other, we will eliminate the x's. So basically if we change their signs. So we have x plus 2y minus 4 equals 0, so that's written down here. And then we had x minus y minus 1 equals 0, so that's written down here. And then we're basically multiplying this entire equation by a minus. So we're going to change the signs. So this becomes minus x, this becomes plus y, this becomes plus 1, and 0 has no sign, so it stays as it is. So now the x's will cancel, x minus x will cancel out, and then 2y plus 1y gives us 3y, and minus 4 plus 1 gives us minus 3, and this is equal to 0. We then bring the minus 3 over the equal sign, it becomes plus 3, and then we divide both sides by 3 to get the y on its own, And 3 divided by 3 is 1, so therefore y is equal to 1. Now we put y equals 1 into either equation to find the x coordinate. So I'm going to go with the top one. So I had x plus 2y minus 4 equals 0. So I'm going to swap that y for 1 with brackets around it. Make sure you use brackets. So you have x plus 2 times 1 minus 4 equals 0. 2 times 1 is 2. 2 minus 4 is minus 2. So we have x minus 2 equals 0. And then we're going to bring the minus 2 over the equal sign. And it becomes plus 2. So we get x is equal to 2. So we have a y value of 1 and x value of 2. So we get the point 2, 1 as our coordinate. So 2, 1 are the coordinates of the point of intersection of M and N.